Here we are in Part 5, page 1010 of Fluid Electrolyte Acid-Base Balance. And we were just speaking about metabolic acidosis, and we've just moved on to metabolic alkalosis now. So in acidosis, we discovered that if we're starving and breaking down fat, we have ketosis, ketoacidosis, and also if we lose our intestinal fluid through diarrhea, we've lost our bicarb component. And so as a result of that, we have lost our alkalinity, and now our body is in an acidic balance. We could go the other way, and we could experience a situation in which vomiting is the primary sign or symptom of disease or pathology. And as a result of vomiting, now there's a tremendous loss of the acidic component, and we've retained the alkaline component. So now we're in a state of metabolic alkalosis. Okay, so those are the main ways in which there's one other way that they've indicated here, but this would be, how would I say, clinical. So sometimes the suctioning, stomach pump suctioning, gastrointestinal suctioning, can have the same effect as vomiting. So we've gotten to the result of alkalosis here. So there's 4 things that we've learned about in summary now. We've had the respiratory acidosis and alkalosis, and now we've had the metabolic acidosis and alkalosis. And we need to take a look at some signs and symptoms here. And so we have a table for that, causes and consequences of acid-base imbalance, and they give us the 4 examples right here in which they're taking a look at respiratory acidosis, and mostly as a result of hypoventilation, something that prevents somebody from breathing properly or taking adequate breaths is going to end up with acidosis. We're retaining CO2. Hyperventilation, in which somebody is panicked or terrified, might end up in a resulting alkalosis. Okay, if you're running hard, you're exercising extremely hard, right, to the point of anaerobic behavior, you're sprinting, in other words, then hyperventilation is going to be just the thing, right, because you're producing a lot of CO2 because the muscles are metabolizing the carbohydrates available, and they're producing a lot of acidity, right? And so there's not going to be a balance problem there. With the balance occurs when you're not exercising and you're hyperventilating, and that might occur basically as a result of fear or stress of some kind. Then we have metabolic acidosis, and again, the how shall I say, the body is divided in areas where we need acid in the stomach and we need alkalinity in the intestines. And so sometimes when we're having diarrhea, then that's going to eliminate the bicarb component and result in acidosis. And then also untreated diabetes ends up causing ketoacidosis. And starvation in general, excess alcohol ingestion can have that similar kind of result. So these are all components of acidosis. And again, they're giving us numbers here that are usually standard values that you can look up. One thing that you can keep in your mind at all times, that we're in a state of acidosis when our blood pH is right at 7.35. That means we're pushing it in the acidic direction. And then we're pushing it in the alkaline direction when our blood pH is at 7.45. So those are our limits, beyond which usually the client is unconscious. Okay, so we had our hyperventilation, hyperventilation. We had here our idea regarding acidosis as a result of diarrhea, and then we also have our alkalosis, metabolic alkalosis, as a result of vomiting or gastric suctioning. Okay, so and we look here and there's going to be we're going to be greater than 7.45, and it's usually going to be too much bicarb. Okay. Then we're going to be taking a look at problems over here on this next page, 10, 11. And the problems are going to involve a patient in which we're going to be trying to determine whether they have alkalosis or acidosis. And these are very typical of everything that you'll be doing as a nurse or a doctor. You'll be getting clinical correlations all the time with, how shall I say, numbers that you have to look at and interpret. And so they give us, for instance here, problem number 1. And also they give us a table down here, so we're always aware of what are the normal values, acid-base, distribution, pH. Okay, what happens if it's respiratory acidosis, right? And what's the distribution? The normal range here for partial pressure of CO2 is 35 to 45 millimeters of mercury. And then the distribution for bicarb is in the blood is between 22 and 26 milliequivalents per liter. Okay, and so once you have your values, then you can look at the information that's being given to you, and we can go over that right here then. And so we'll do this first problem here, and let's take a look. It says note in this first problem, note the pH. So let's consider, here we are in problem number 1, and it gives us a blood value of 7.6. That's way out of line, right? So we have a range of 7.35 to 7.45. That's crazy. Okay, so this is really alkaline. And the partial pressure from CO2 is 24 millimeters of mercury. And what is it supposed to be? It's supposed to be between 35 and 45, right? And so it's very alkaline if we have less. And in fact, we have quite a bit less here. We have only 24, where the bottom end of our range is supposed to be 35. So we could say, oh my goodness, we're having respiratory alkalosis here. This person is freaked out. They're breathing too hard. They're probably just terrified. And we need to get them some sort of a bag to breathe into so they can re-aspirate their CO2. And over here we see the milliequivalents of bicarb is 23 milliequivalents. And over here the normal range, oh, we're in the normal range. 23 is between 22 and 26. And that's usually the way it is with respiratory is quick and the kidney is slow, right? So something has just happened and they have a panic attack and the kidney has not yet compensated. So if we go over and we look at the information that they go over here, it says note the pH and anything that's greater than 7.45, check the PCO2, and then check the basically this next step, last step is check the next part of the problem. And they do go over the problem here, and here's the analysis. The pH, it says, is elevated. We're at 7.6, which is way high. And then number 2, it says the PCO2 is very low, and that is the cause of alkalosis. If you don't have enough CO2, it's not going to be in balance. And then it says here that the bicarb value is within normal range, and the conclusion is that this respiratory alkalosis is not compensated by renal mechanisms, as might occur during a short-term hyperventilation. Okay, and we'll pick up the next problem in the next section here.